Here's our issue today, guys. Looks like, is this a 0 zone? 71 degree box temperature. Model and serial number. So you see we're pretty much emptied out. Let's check our airflow. Fans are spinning. Let's check our airflow down here. Airflow looks good. One thing I do need to get at down there is our liquid line solenoid, just to make sure that is getting a signal to open. Put this back in here. Alright, so hearing is our high box temperature alarm. On this cooler, I believe it's set at 45, maybe 50. But what I want to do before I go out and inspect my condensing coil is I first want to verify that we have power going down to our liquid line solenoid. So, right over here, there, that's our liquid line solenoid. You see one side of it is our neutral, followed down to 18 gauge blue, which leads over to this, our blue, which leads over to number 2 on our Corel control, or Corel rather, our Corel control. So if we come over here, we'll see right there, that little sideways triangle thing is our call for cooling. So right down here, blue, this is the wire going to our liquid line solenoid. So we do have power to our solenoid. That means our pressure switch on our condensing coil should have closed and kicked on our compressor. So let's make our way out to the condensing coil and see what's going on over there. This is our guy right here. As you can tell, we're not cooling, we're not doing anything, nothing's running. Sight glass looks full. So first things first, our disconnect is locked. Manager doesn't have the key to it, so first thing first, I'm going to pull this panel off right here and check my incoming voltage. Alright guys, now this is a 208, 230 single phase unit, so I should have 208 right here sitting at the incoming side of my contactor, which I do. I got 212. Let's check our contactor. I believe this is, yeah, so our contactor coil is a 208 coil. So I'm just going to go across here, and I should have 208 if it's closed. I don't have anything. That means, since I don't have anything on there, my contactor doesn't have a call for cooling. I have 120 on one side and 120 on the other side. Now, an old guy once told me that when you're measuring or playing around with 208, 230, single phase, triple phase, you can confuse yourself if you're just checking everything to ground. So just remember that. Again, checking across both sides of my contactor, I have 0 volts. If this was a 24 volt contactor or a 120 volt contactor, then I could assume that my contactor is closed, or should be closed rather. But since we're dealing with 208, it's a little bit of a different story. So what happens on this system, for those who aren't familiar with it, inside our evaporator, that liquid line solenoid that we were talking about earlier that we checked to make sure was getting proper voltage from our Corel controller, that will open, and when that does open, our pressure switch right here will sense that pressure, and it will send voltage to one side of our contactor. Right through, well, let's see. It'll go through here. It'll go through our head pressure, our thermal, which is right there. And then after it goes all the way through those two components, then it goes into our other side of our contactor. And then when the unit pumps down, that solenoid inside the box will close. Our compressor will continue to run, and it'll basically, it won't pull it down into a vacuum, but it'll pull our low side, our evaporator, our suction line, all of that down to, I don't know, 3 to 5 psi, whatever it's set to. It'll pump everything into the receiver, into the condenser, and then it will shut off on this low pressure switch. And then again, just recapping, when that liquid line solenoid opens inside that evaporator box, when our Carroll control says, hey, it's time to cool, it'll send power to that liquid line solenoid. That solenoid will open, releasing pressure throughout the system. This switch will sense that higher pressure, which I don't know, usually 30 psi roughly. I could be completely wrong, but just throwing a number out there, but usually 30 psi, and then this will kick on and it'll run until it's switched off on low pressure again when the unit pumps down. So that's just kind of a quick summary of it. So now we know our contactor doesn't have proper voltage to close. So our next step in the circuit is going to be this. I suspect this isn't closing, probably because it's low on charge. I mean, 99% of the time that's what happens. All right, guys. As you can tell, we're gauged up, hooked up, and we have 2 psi and 2.6 psi. So we are definitely low on charge, just about completely flat. I'm actually surprised we have anything in there at all. Now, some of you guys out there that aren't familiar with pump down systems might be wondering, well, couldn't I just be in the pump down state? Let's imagine for a second that this unit was fully operational and it was cooling and it just shut off and pumped down. And as I just explained a little bit ago, the compressor runs until our low pressure switch right over there senses about roughly 3 to 5 psi, whatever you have it set to. I prefer 3, 2 or 3 is what I prefer. And there's variances on what refrigerant you're running, what kind of system it is, but I normally operate on a rule of thumb of 3. So let's say this unit just shut off and we pump down. Now it would be normal to see 2 or 3 psi on our low side, but remember when we're pumping down, our compressor's pumping all that extra refrigerant into our receiver back there and into the condensing coil, which is a microchannel in this case, so a majority of it's going to go into that receiver. So that means when I attach my gauge to my high side, I should have a much larger pressure differential. Probably in this situation, whatever's closest to ambient. I think it's probably about 80 degrees out here, and it's a 404 system, so it would definitely be much higher than 2 psi. So we have a leak somewhere in the system. So what I'm going to do next is add about maybe a pound of R404, because we have a very long line set at this location. So I'm going to add about a pound of R404 and back that up with about 150 psi of nitrogen. And then we are going to listen and sniff around with my electronic leak detector, see if we can't figure out where this leak is. All right? Real quick, guys, before I add my tracer gas, I want to point something out. Now, when I put 150 psi of nitrogen behind this tracer gas, that pressure switch, assuming it's not broken for some odd reason, will be satisfied, it'll close, and it'll want to kick our system on. Now, in this situation, I don't want the system running with a mixture of nitrogen, mostly nitrogen, and a little bit of R404. So I am just going to pull a wire off of this contactor so it doesn't kick on, because we are locked out of our disconnect box. So, or excuse me, the one down there. So keep that in mind, guys. Got about 167 psi of nitrogen and R404. I have my gauges disconnected. After I pressurize it, I disconnect my gauges just so I can check my ports. Nothing. I sweep around any sort of metal on metal contacts, any joints obviously. These accumulators tend to sweat a lot, so they can rust out. This one's in pretty good condition actually. Now I'm just going around this cap. When I'm all done sweeping everything, I'm gonna pull that cap off and check that a little bit better. I just don't want to disturb anything yet until I do my initial sweep. Well, so far I'm getting nothing. Let's go around to the front of this. Just sweep this condenser a little bit. Try to get down there and just see if I can get a hit on any of these elbows. If I do get a hit this way, what I'll do is I'll pull this side panel off. Let's see if that was a real hit. Well, we might have something down there. It was only a little tiny hit, so. The other difficult part is it's a windy day out today too, so. I honestly don't know how much that affects this leak detector, but you know, this is a micro-channel coil, so there's not actually any elbows down there like I said originally. It's just a header on both sides. One side will be a hot gas header, and then the other side will be a liquid header. Alright, so I got 2 or 3 hits on this side. Even though they were little hits, I'll have to pull that side panel off and further investigate. So what I'm going to do now is pull all these caps off, so when I pull that side panel off and check there, I can check the rest of these caps and service valves as well. As you can tell, we have our side panel removed. Just checking the connection points of our condensing coil. Well, I guess it must have been a false alarm. I did reattach my nitrogen since I already checked those ports, those service ports. And I wanted to make sure I had a steady 150 psi. I'm not getting any hits out here on anything. That wasn't a hit, I just bumped the end of it. Alright, well, since I don't have any hits out here, my next logical step will be to go inside, check my evaporator and whatever line set I have access to over there. Alright. Not sure if it's picking it up on camera, but there is a distinctive hissing noise. I'm going to end up soaking all this in bubbles just to confirm. So my detector was going crazy for a minute there. No, we got nothing. As soon as I get a hit, I like to remove the leak detector and let it reset with some fresh air. So let's go back to where we were. Alright, I'm getting a pretty good hit there. Let me get some bubbles on this. I believe our leak is right over here on the outlet side of our TXV. Right there. So first, let's see if I can drip some bubbles on there. Right there, that's a good one. All right, she's blowing bubbles. So it's been about a week since that last clip you watched. We are back on site. I finally got approval from the customer to repair the leak on our TXV, on the outlet of our TXV, our evaporator inlet, as well as replacing the filter dryer, pulling a vacuum, and recharging. So right now I'm just going to hook up my nitrogen and get a steady flow of nitrogen on the inside so I can fix that leak at the TXV. And then when I get back out here, I'm going to get everything kind of set up, get my vacuum pump, scale, and everything hooked up. We are sort of in a back alley behind the building, so I don't want to get everything set up here and then go inside to fix the leak, leaving all my equipment out. So that's why I am not prepared yet. As you can tell, I got my nitrogen hooked up, floating between 3 and 5 psi. Got my core removal tools on here. Our nitrogen's going down into our liquid line, up through the line set, into the building, into the box, into the inlet side of the TXV, and out the outlet side into the evaporator, where it comes back out to our suction line right here. So we are steadily flowing nitrogen. Let's get inside there, fix that leak. Alright guys, so today I'm going to be using this wet rag from the Viper refrigeration products. First time I've ever used it, so let's see how it turns out. Feels pretty nice. Consistency of Play-Doh. Feels nice and cool. It's not all dried up like my last Hot Block product was. So what I need to do is contact John Pastorello and see if he can make me some sort of flame resistant beard balm, flame resistant to beard oil, sort of a hot block for your beard. I don't know, John, if you're watching this, what do you think? It's not too bad of an idea, is it? Alright, so we got the top of our TXV protected. Let's see. Let's fire up this torch now. things didn't go as well as I thought they would. I wasn't able to seal up the top side of that TXV as well as I wanted to. I don't know if it'll show it, but there's a substantial problem on the bottom side of this where it looks, let me get my mirror over here to show you. Let's see if you can see underneath there, there's a hole in my tubing. Now, I know my torch wasn't hot enough to do that. So I believe, since I was here the first time and when I found the leak, I didn't check the bottom side of that. I believe that was our initial problem. So I pulled a piece of copper out, and what I found was the end of the copper is pinched. Not real sure why it's pinched. Yeah, not sure why it's pinched like that, but so what I'm going to do is attempt to just cut about 1 inch off the top of that TXV and re-braze it, seal it back up, and get this thing back up and running. So here is my on-the-fly repair of that piece of tubing that had been melted through. Came out pretty good. Hindsight being 2020, I would have just quoted to replace that TXV as well. Had I had looked further and swiped a mirror on the back side of this and seen that when I was originally here, I would have just quoted to replace that as well. But anyway, we got her all sealed up. So swap out this dryer and we'll pull a vacuum. Here's where we're at. Got my filter dryer replaced, as you can tell. And with this one, what I did is I just cut the old one out right here. And it was easier to pull it off, because if you try to pull this off like this, you heat this side up, you pull on this, you'll probably crush it or bend it or whatever. So normally what I'll do is I'll just cut it right there, and I just repipe it, just throw a new piece of pipe on here, swedge it open, stick it onto my receiver. Bottom side looks nice and tight. We are under pressure right now, roughly 145 psi. So I'm gonna let that sit for a good 10-15 minutes, maybe clean up some of my mess here, and we'll see if she's holding. It's been about 15 minutes now, and we're still holding strong at 144 psi. So what I'm gonna do is take the nitrogen charge that's in the system, and I'm just gonna use it to clean out this condensing deck, because it's full of dead grass and whatnot. Alright guys, let me bring you up to speed real quick. As you can tell, my core removal tools are off, and I have another line going from my vacuum pump over to a valve back here that's used to isolate the compressor during changeouts. So what had happened was I got the microns down to about 520, and I let the vacuum pump run for another 20 minutes, but I couldn't drop it past 520. So I broke my vacuum with some nitrogen. I just blew nitrogen through there, shook the compressor around because I suspected maybe there was refrigerant or something trapped in the line set. We have about 70 feet of line set on this system. So I broke that, and then I took my core removal tools out, put my hoses back on there, attached my 3/8 line, and now basically I'm pulling from the 3/8 line, measuring at my micron gauge, which is the lowest point in the entire system. As you can tell, we are down to 420 microns. I've been holding at 420 for about almost 15 minutes, I'm gonna say. I got my tank all hooked up, my scale is zeroed out. So we are going to weigh in 5.5 pounds of refrigerant. I did talk to tech support just so because I wanted to not only get the volume of that receiver, but I also wanted to calculate the charge or or figure out the exact charge based on line set length. And again, we got a pretty long line set in here. It goes up the wall, into the building, across the building, over to the units. So it's a long run. I figure it's about 70 and maybe 80 feet. So tech support says 90% of this receiver volume is going to be about 5.5 pounds. So I'm going to start there. And they said no more than 6.5 pounds though. So I'm going to start at 5.5, see how our sight glass looks, our pressures and everything, and then we will kind of go from there. Just a little over 5.5 pounds. It's no big deal. So what I'm going to do is let this stabilize for a little bit, because I did add a little bit of liquid onto the suction side. And I know I have an accumulator, so there's probably no risk of turning it on right now and sucking liquid refrigerant back into the compressor. But I'm going to let it equalize just for a little while. Plus I got to clean up some of my mess over here. And then I got to go inside and find the breaker for the condenser and turn it on. So I will be right back. Just wanted to show you guys this line set, kind of tell you some of my concerns. My concern is that there's no trap that I know of. There might be one behind the cabinet, but I don't know. But I don't believe there's a trap for oil return, because it goes straight down through the cabinet behind this false wall that air comes through. And it looks like it just goes straight into the evaporator. And as you can tell, it goes over there up into the ceiling, but there doesn't seem to be a particular pitch at all in that line set. So let's take a walk. All right, so we've been operating for about 10 minutes. My current pressures are 183 over 50. Evaporator temperature is 16, condensing temperature is 82. My ambient temperature today is about 63, 64 right now. It's changing a little bit though, because I have clouds that keep on moving in and out. Anyway, evaporator temperature is 16. Now this is a cooler we're working on, so a rule of thumb on coolers is usually 20 to 25 degree evaporator, because we want to maintain a box temperature of about 35-ish, 34 to 38. It's basically a pop cooler. So that's a little bit low. Superheat 45, and we're measuring it at the condenser, as well as we have roughly 70 feet of line set going through the building. It is all insulated though, as you've seen from the last clip there, but it is all insulated, so I would expect 20 to 30. So I believe that's a little high. Subcooling's a little bit low. And our sight glass is bubbling. Now I was prepared for the bubbling sight glass, because the calculation from tech support said that no more than 6.5 pounds in the system for the line set. I put 5.5 just because I didn't want to overcharge it off the bat. So I'm going to slowly add in another pound of refrigerant and clear my sight glass and revisit my pressures. All right guys, so I ended up adding about another 3 pounds to the system for a total charge of, I believe it was 8 pounds, 8 ounces altogether. And I believe that was because I grossly underestimated how long that line set was, because it goes the entire length of this building. So it's probably closer to 80, 90 feet instead of the 70 feet like I told tech support when we were initially calculating the charge. So we are basically all set. My units just pumped down a little while ago and then turned back on. Pressure's 185 over 45, so we're doing pretty good. I'm gonna go inside, check my box temp, and then we will wrap this thing up. It's looking a little bit dirty in there. But we are at 35 degrees, so we are all set here. 34. Good, good. All right, guys, that does it for today's video. As you've seen, we were down to temperature. My pressures look good, system pumped down, and it shut off just like I wanted it to. So we're all set here, guys. Hope you enjoyed the video. Thanks for watching. Hit that like and subscribe button for me, will you? I'll see you on the next one, all right?